In this example, we are asked to use Mathematica to locate and classify stationary points for a particular quadratic function as given here, and then plot a graph just to check our results. So, getting up a Mathematica window here, firstly let's put in a function here. We'll call it f is equal to x squared minus 6x plus 12. Now we're looking for stationary points, so what we really need to do is find the derivative df by dx, or f dashed of x, and then set that equal to 0. So we'll call the derivative df. It's a derivative of f with respect to x. So we process that minus 6 plus 2x. Now at a stationary point, this derivative is going to be equal to 0. So let's solve the equation. Solve for df is equal to 0, solving for x. And it tells us that x is equal to 3. So we will have a stationary point at x is equal to 3. We will later on calculate the value of f at that point. Now, in order to classify the stationary point, is it a maximum or a minimum or possibly something else, we need the second derivative. So let's call the second derivative df. So that's the derivative of df with respect to x, and that is equal to 2. The second derivative is equal to 2, well, everywhere, but in particular at the stationary point where x is equal to 3. So because the second derivative is positive, our point is a minimum. Now we really should just check the value of f at that point. So if we set x equal to 3, our stationary value as given here, and then let's check the value that f takes, f is equal to 3. So it would seem that we have found a stationary point at x is equal to 3, where f is equal to 3, and it is a minimum. Well, just to be sure, let's plot a graph to check this. So we'll make sure that we're plotting for various values of x, not just the x equals 3 that we've put in. So when we plot f as a function of x between, say, x is 0 and x is 5, here is the curve that we come up with. X along the way, f up the way, and let's just put in a plot range from -1 up to 12. We can see here we have our minimum at x equals 3, and the value of f we see from here is equal to 3. So a minimum at the point 3, 3, found it using calculus, but checked it by plotting the graph.